In this video, we're going to take a look at an interesting zone-based routing capability that's new in release 6.2 of the Curity identity server. This feature is useful for global systems where we can route OAuth requests to the user's home region. This ensures that personally identifiable data is stored in the right place, which is good in terms of meeting privacy regulations. So let's take a look at the end-to-end solution we're going to run. We're going to have a client application and two users, one from Europe, one from the USA, and depending on which user it is, they'll be routed through to the correct instance of the Curity identity server, and the two instances will use completely separated data sources. On the technical side of things, an interesting feature of the 6.2 release is the ability to use wrapped tokens. These are confidential JOTs that are readable, and we will store a zone value in either a wrapped token or a cookie, and this can be read by a small plugin running in the reverse proxy, which will do the routing for us. So next we're going to get an end-to-end solution working. Our demo will use Docker images so that it's easy to run the entire system on a standalone computer. First though, let's have a look at the HTTP requests. We're going to use OAuth tools as a test client. Instances of the Curity identity server will run internally within a Docker Compose network, and endpoints will be exposed to the host computer via a reverse proxy which runs at localhost port 80. In order to get OAuth tools to connect to the reverse proxy, we will use an Nginx tunnel, and we'll show how to get all of this set up shortly. The interesting part of the demo will be how the plugin reads the OAuth requests and routes the user to their home region. So next we're going to run some code resources that automate this setup. In Curity's GitHub repositories, there's one called Dynamic User Routing, and this enables you to automate the setup so that you can see how the routing works. It's pretty straightforward to run. The README file has all of the instructions, one of which is to copy in a license file, which you can download from the developer portal. We're going to go through the interesting aspects of the setup, which involve running this run script. So let's do that. And we also need to give it, tell it which reverse proxy to use. In this video we're going to use Nginx, but you can also use Kong open source if you prefer. So let's kick that off. And the first thing the script will do is it will generate an ngrok URL, and this enables us to connect from OAuth tools on the internet to our local system. So we're going to copy that and click enter. The script will continue by spinning up a Docker Compose network, and within OAuth tools we're going to create an environment, use the use web finger option and copy in the URL. I won't actually click discover until all of the containers are up and running though. In the meantime, let's have a quick look at the Docker Compose file. As we can see, there's an instance of the Nginx reverse proxy. You could run Kong if you preferred, as I just said. There's a Curity admin node which we'll look at later in the video to understand the settings. There are separate instances of the Curity identity server for Europe and the US. And both of those instances use different data sources. There's a European data source with a single test user and a US data source with a single test user as well. So this really gives us a fairly real-world setup on a developer computer. If we go back to our script, we'll see that all of the instances are up and running now. Runtime node is connected to admin node. So we can return to OAuth tools and click discover. And we now have an environment ready for testing. So we can select that environment, and in the next section of the video, we'll begin testing. If we return to OAuth tools, there is a pre-configured client that we've just deployed with our system called Tools Client. It has a client secret of password1 and a simple scope of OpenID, and we've selected our test environment, so we're all ready to begin testing. And what we're going to do is log in as both a European and a US user and have a bit of a look at the log entries in the reverse proxy to understand what's going on. So in order to do that, we're going to run another command called logs for Nginx. So the idea is that we only want to see the log entries for Nginx and not the other components. So I'm going to drag this window over here, and now let's start a couple of logins. So first I'm going to log in as the European user, and one thing to notice is that there's two steps involved in the authentication. So we're actually putting up a username authenticator first to identify the user before we're actually doing the verification of credentials. So let's do that and see what the result is. So the system has calculated a zone for the user of EU. And when we click continue, it will make sure the user is in the right region when they hit this screen so that the credentials are verified in the location where they're stored. So I'm going to log in as this user. I'm then going to redeem the authorization code for tokens in the standard way. And one thing to notice is that there are three values here for the authorization code, the access token, and the refresh token. And they're all a bit longer than usual because usually in Curity what you see is a short opaque access token. What we're actually using here is a wrapped JOT instead. So what I'm going to do is copy that value and paste it into the JOT token screen. And what we'll actually see is this is now a JOT, but it's a very confidential JOT. So the idea is there's no sensitive user information revealed here, but the only thing that's revealed is a zone that can be used by middleware to actually route the request reliably, which is what we're doing here. Let's carry on and do a login for the US user next. And again, we're identifying the user in this screen. So the idea is that the user identification doesn't need any personally identifiable information, and this could be driven by a data source or something that could be replicated globally and is completely separate to the regional data sources, which is where the private information is stored. So if I hit next this time, then what's happened now is we've calculated that the user is in the US zone. So when we hit continue now, the user will be directed to the US instance of the Curity identity server. We can log in again, we can redeem the code for tokens. So what we've seen is that even though the two users require completely different instances of the Curity identity server, the routing is reliable. And it always takes the user to the correct location. Let's have a quick look at logs. What we'll see is that we see some entries such as found zone US in cookie or found zone US in wrapped tokens. And if we scroll up a bit further, we'll see there's some European entries here as well. So what we've demonstrated is that the reverse proxy has the intelligence to actually route the user reliably. And next, we're going to have a closer look at how the reverse proxy does this. Next, we're going to take a closer look at how the reverse proxy routing works. So if you open the GitHub repository in a code editor, then there's three files that implement the routing. First, let's look at the Docker file. First thing to notice is that we're using the OpenResty version of Nginx. The reason we're doing that is it comes with a nice scripting language called Lua, which makes it very easy to extend the system via plugins. We're deploying a plugin called Zone Transfer, and we're also including a third-party library called Lua Resty Jot. And this is useful when we want to read the zone claim from wrapped tokens. Next, let's look at the Nginx configuration file. So we have a map of zone values to host names here. So typically the host name would be the load balanced URL of the reverse proxy in each region. The host name is then passed through in a call to proxy pass, which sends the request to the Curity identity server. So the idea is that the correct zone host name is calculated for the user. The real logic is in calculating this zone value, and this is done within a Lua block down here, and it's fairly straightforward. We have some configuration that we can pass in, then we create our plugin via this require statement, and then we ask it for the zone value, and the plugin will inspect the HTTP request. So if we look at our plugin, this is pretty simple code. It just goes off and does two things really. First of all, on front channel requests, it looks for a cookie to see if there's a cookie containing the user zone, and if it's a back channel request, a post message, we look in the request body, the form body here. So there's a bit of logic in here, but it's all quite easy to follow based on inspecting the HTTP request, and you could code this logic in any language quite easily. And so the key point about this really is that although we're using Nginx, this will work in any reverse proxy or API gateway that has good support for content-based routing, which is what we're doing. So finally, we're going to move on to describing the configuration settings. I'm going to finish up this video by looking at the configuration settings in the Curity Identity Server. So the GitHub repository explains how to log into the admin UI, but it's just a default URL that we use for development, and you can log in as admin password 1. First thing to notice is that we have a global system with an admin node, a single European runtime node, and a single US runtime node. So what we're going to do is we're going to show that the Europe and US instances manage different user accounts, and we're going to show how that's wired together. So it all starts under system zones, where we define a zone for Europe and a zone for US. These are just identifiers. And more interestingly, if you go to service roles, what you'll see if you edit one is that the zones are mapped to service roles. So when an instance of the Curity Identity Server starts, it is given a service role, and what this means is that once an instance is up and running, it reliably knows what its zone is. So, once the US instance is running, its zone is always US, and it will always go and get data from a US data source. And the way that that's managed is via a multi-zone data source here. So if we look at this, what a multi-zone data source does is it looks at the running instance's zone and then maps it to a concrete data source. And using this mechanism, we separate the European and US user accounts. If we look at one of these user accounts, we'll see that there's different host names used within our Docker Compose network, and therefore the data is completely separate. So next, let's look at the profiles. So even though we've got two service roles, we're not duplicating any settings. They both use exactly the same OAuth settings defined under the token and authentication services. If we look at token issuers, we'll see that the multi-zone data source is referenced in a few places, and hopefully this makes sense that a US instance would always then go off to the US database. The other interesting section here is around use-wrapped opaque tokens. So as we saw earlier, this will ensure that the wrapped drops are used so that the zone can be used by middleware such as reverse proxies. Let's look at under scopes. We've got an OpenID scope, and we've included a zone claim in it. The zone claim is just configured to use the system claims provider, which will just determine the service role, and from the service role it will get the zone and issue that into tokens. So it's fairly straightforward from a token viewpoint how to deal with zones. Next, let's look at our test client. So we've got our test client is called Tools Client, which we used earlier. We've got a scope of OpenID, and under user authentication, we're using simple username password authentication. Where it gets it more interesting is under the authentication service, because we've split authentication into two steps. Username is about identifying the user and the zone, and username password is where the credentials are verified. So the first of these can run in any region, but the second of these must run in the user's home region in order for logins to work. And as we saw earlier, the routing is reliable and ensures that that will happen. If we look at the username password authenticator, it has a prerequisite of the username authenticator, which means it can operate in password only mode. And we saw that working earlier. Finally, to finish up, the username authenticator is the more complicated area. So there's three main stages here. The first one is to actually set the zone, which requires some logic. So therefore, this is a script action. The next action is a zone transfer action, and all this really does is writes a cookie and proceeds to the next stage of authentication, and then the reverse proxy can reroute the user if required. So it's a fairly simple mechanism, but it enables the reverse proxy to do the right thing. And the debug action just gave us some visualization earlier. We would turn this off in production. The set zone one is the more interesting one because we need to run some logic to actually say which zone a user is associated to. In our example, we are using a very simple option. It's kind of like a email suffix, which people might have different email suffixes per region, in which case this type of option would be sufficient to check the suffix in the username. But in other cases, you may require a different solution, such as a database that maps all users to their zones. And you could potentially use things like authentication actions to ask the user for their zone as well, if that's appropriate. So that's all of the steps. The authentication step is the trickiest. But once done, you're going to have a very nice system where the user data is elegantly separated, and there's quite a bit of good reliability in the system as well. So that's our end-to-end system described. And just to finish up, so there's further information available on the Curity website. This includes some guides around how to implement this solution in various API gateways and reverse proxies. So thank you very much for listening.